Hi everyone, welcome back to our YouTube channel Sid Education. In this video, we are going to write the algorithm which we were using in our previous videos and going to trace again with one more example the same algorithm, right? So merge sort algorithm. So what is the purpose of this merge sort algorithm? We need to recursively simply sort the array using merge sort. That is what we are going to do with this algorithm which we are going to write it. If I talk about input, you will be having unsorted array, okay? Unsorted array which will be of the form, let's say from left to right. What will be the output? Output will be nothing but sorted array that is also A of L to right, left to right. Okay, so we need two things. That is first is merge sort function, okay, which is array left and right. So what you are going to do, if your left is less than right, then what is the middle element? If you remember, it is left plus right by 2. Okay, I'll just trace example with you here, okay, side by side. For example, let's say you have 34, 7, 23, 32. So what you do, first you divide from the middle. Middle is, this is left, this is right. So left plus right by 2, that is 1.5. Its integral value is 1. So you divide. So you get 34, 7, 23, 32. Then again you divide 7, sorry, 34, 7, 23, 32. Then you merge. You merge with the help of an auxiliary uh, one more temporary array called as B. What you do, you check whether A of I is less or A of j is less. If A of I is less, you increment I and you increment k. If k is the left element here, and what you do, you copy A of I element to that. If A of j is less, you increment j and you increment k and copy A of j into B of k. You remember? Then what you get? You get from here 7 comma. So if I remove this, what you get is you get 7 comma 34. You get 32 comma 23. Sorry, my bad. 23 comma 32. Then when you merge this, you get 7, 23, 32, 34. Something like this you get, right? So I was talking about this merge. So what merge you need to do? You need to apply merge sort two times on this, and you need to apply merge here. That is, you need to apply merge sort on A, L, M. Then again you need to apply merge sort on A, M plus 1 and right, and you need to apply merge operation on A, L, M, R. Are you getting it? So this is how the merge function look like. Now, what I was talking about A of I and A of j comparison, that will see in this merge function. So if I have to write this merge function, so this merge function will have what all elements? A, array, left, middle, and right. So you initialize I to the left and j to the m plus 1. You remember? Uh, if I want to trace it again, so let's say I have to combine 7, 34, 23 and 32. So I initialize I here and I initialize j here. That is left. And this is what? This is m, right? This is m, so m plus 1. That is j. And what we used to do? We used to have a temporary array of size n. We used to have k here. Now to that k you can initialize. So what we used to do? We need to check whether a of I and a of j which is less. Whatever element is less will increment they. For example, here if I consider 7 and 23, so a of I is less, so we used to copy a of I, increment k and increment I. That is what we are going to write. So what we are going to write? While I is less than equal to M and J is less than equal to R, what are you going to do? Compare. If A of I is less than A of J, so if A of I is less than A of J means I is less than, what you're going to do? You're going to put your I element in the temporary array and going to increment K and going to increment I. So I have written this way. Else, what you are going to do? You're going to increment K and you're going to copy J and you're going to increment J. And if you have exhausted the limit, you're going to copy everything. That is, while L is less than equal to M, if you have everything, you just copy everything. If you have exhausted all things from J, you copy everything from I, or if everything is exhausting from the other side, right, then you copy everything to that temporary array, right? And then what you do at the end, you copy all the elements of B to A. So this is how the algorithm looks like, right? We are going to see the execution of this algorithm in IDE. So there you will have a clear thing. But this is the trace, right? This is how the algorithm looks like. If you have seen our previous videos with examples, you will have got it what I have written all of these, right? So this is how it is done. So if you liked the video, please do like, share and subscribe. In our next video, we are going to derive the time complexity and space complexity for the merge sort, and there will take another example to conclude on merge sort. We are also left with a concept called inversion count, which is related to merge sort, right? So I wanted to give that brief here. So in case you are still wanted to get what is inversion count. So inversion count is nothing but it talks about how far is your array from getting sorted, right? For example, if your array is already sorted, then in that case inversion count will be 0. If your array is reverse, it's sorted in reverse order sorted, right? Like 4, 3, 2, 1. In that, your inversion count will be higher. Okay, in that case your inversion count will be higher, right? Because for this you need to repeat for this to this element, you need to compare, and for this you need to compare this, and for this you need to compare this. That is 3 plus 2 plus 1 plus 0, that is 6. So that is what inversion count, which is based on the merge sort, right? We're going to take example and the inversion count also. I just wanted to conclude this, that's it, right? Thank you.